Well, hello, this is Miss Becky again. Excuse me. Today we're going to be going over IXL section R12 trig ratios so that we can find the missing side of a triangle. Um, Excuse me for coughing there. But we're going to be going over the how to find a side of a triangle if we're given an angle and one side. And we're going to be using these trig ratios right there. And also, our answers will be simplified, so they're going to have radicals in them that look like this. Those you can put in your calculator, and it's going to spit out a decimal, but that is not a precise value. So some of them we will use the calculator, and I'm going to hopefully show you how to do that on the TI-84. All right, so let's just jump right in here. We are on example number 1. Um, we are given, we know that we have a 60-degree angle right here. So we need to look for our clues what we have. Um, and we also have the length of the hypotenuse, which is 14 square root of 23. So this is hypotenuse. Um, but we are told to find side GI. That one is the side right here. That's what we need to find. So I'm going to label that X because we don't know what it is. Now, gonna first thing that we need to do is figure out which one of these trigonomic ratios here, um, oh wait, well, give us the hypotenuse, and then this is the opposite side of this 60-degree angle. The ratio that uses the opposite over the hypotenuse is the sine ratio. Um, so we're going to set that up. Sine 60-degree angle equals the opposite side, which we don't know what that is, over the hypotenuse, which is 14 square root of 23. Before I go on, I just want to make sure that you realize that IXL, they want our answers in a simplified, rationalized form. So again, that means that we're not going to be using a calculator because we want those radical signs in there. So we did step number 1, which is right here, which is to set up the equation using the correct ratio of sine, cosine, and tangent. Sometimes that's where people make errors. So the second step here is to solve for x or rearrange the equation so that x is isolated. Now, a little side note to that, to solve for x, you want it to be isolated by itself, so you need to get rid of anything that is being done to the x. So right here it's being divided by 14 square root of 23. So we need to get rid of this. So to do that, since it's being divided, you would then multiply this side by 14 square root of 23. Now, what you do to one side, you have to do to the other. So we would multiply this side by 14 square root of 23. What ends up happening is these two cancel out, leaving x all by itself, right? And then, so what we have now is 14 square root of 3 times sine of a 60-degree angle. Now, before I go on, I want to show you a little shortcut with this part. You don't have to do, you know, this necessarily. All you need to do, if you look over here, if you have one fraction that is equal to another fraction or ratio, they have certain moves they're allowed to make. So these two, the A and the D, can slide to those positions. So I could move D up here, um, and would leave this. So these two can be moved, and that would leave nothing for 1. Um, other thing I can do, oops, is, sorry about that. These two are interchangeable. They can slide just like that. So sometimes it's just easier to slide them. So I could have just taken this whole term right here and just slid it up there and saved all that time. But I digress. Okay, step number 3, we are going to replace the trig ratio value with the cosine sine values from the unit circle over here. Which is so very helpful. So the trig value that we have here is the sine of a 60-degree angle, right? So we're going to just bring this down. We have 14 square root of 23 times the sine of a 60-degree angle. We'll go over here, we'll find our 60-degree angle, which is this large angle with the green side. And so the sine, if you'll remember, is the y value for cosine and sine. Cosine is x, sine is y. So we will replace that with square root of 3 over 2. Okay. Going on to our next, let's see, we've done step 2, we've done step 3, step 4. We want to solve the equation. So simply here, we need to multiply 14. When you multiply these radicals, well, regular numbers go with regular numbers, and radicals go with radicals. So it's going to be 14. There's nothing else to multiply it by, but a square root of 23 times the square root of 3 gives a square root of 69. That's all divided by 2. Our next step is these are regular whole numbers, so we have 14 divided by 2 is 7, and we can't do anything more with this. So that is our final answer to find this missing side right here. Okay, this is number 2, problem number 2. Always look again to see how IXL wants your answer in what form. This one on your notes says that they also want it in radical form, simplified. So step number 1 is we're going to set up our equation using correct trig ratio, sine, cosine, tangent. So our first clue is we're dealing with a 45-degree angle. We have an opposite side here, and that is square root of 3 times square root 11. It's the opposite side. Now, what we are told to find is side WX, which is this side right here. Okay, that's the one that we don't know, so we're going to label it as X. And it is adjoining, it's touching the angle, so it's adjacent or adjoining. Now we just need to figure out our ratio. Which one has opposite over adjacent? And that looks like right here, tangent. We'll tell you that, wait a second, let me check. I'm going to say I will tell you that these tangent ratios involve a little bit more work, and I'll show you that in just a second. So the tangent is the opposite, which is 3 square root 1 over the adjacent, and that's the one that we don't know. So we did step 1. Step 2, we want to solve for x or isolate x. So we've got x down here in the denominator. I could just switch these two guys out. I can move them. So I'm going to put x up here. I'll leave this up here. And the tangent of a 45-degree angle, put that down there. Step number 3, replace the trig ratio with, this tangent, the 45-degree angle, with the precise value on the unit circle. If we're going over here, we're dealing with a 45-degree angle, which is the blue line right there. It's 45 degrees. But we only have cosine and sine. So if we're dealing with tangent, that's right up here. We have to replace the tangent value with a sine over a cosine. So I'm actually going to do that over here, right? So tangent, I'm just going to do this off to the side. 45 degrees, I'm going to plug in the sine value. Sine value is, again, the y value, which is square root of, square root of 2 over 2. And the denominator, we want the cosine value. That's also square root of 2 over 2. Now, this is complex fraction and it looks a little funky, but you remember you have the same number, the numerator and the denominator, it just equals 1. So this all just really equals 1. Okay, so the tangent of a 45-degree angle is always going to simplify down to 1. So let's just write that over here. X equals, this stays 3 square root 11, taking out that tangent of a 45-degree angle, and it's 1. Now, you know that if you have any number over 1, so again, 5, if that's over 1, it just equals 5. So here, x just equals 3 square root of 11. That's our answer. We are on to example problem number 3 here. And I will give you a warning. This one is kind of lengthy. So can't help that. Let's just jump right in. Now we want to set up the equation for 1, set it up. Let's look for what we have here. We have a 30-degree angle. We have an adjacent or adjoining leg. This one is adjacent. That being really careful not to make a mistake because this is my 4th time making this video. Anyway, all right, so we're told to find the x, which is this leg right there. That's what we don't know. Okay, we don't know what it is, so we're going to label it x. And its position is its opposite of the 30-degree angle. So what we're dealing with is an adjacent and an opposite. And again, that's the lovely tangent, which requires us to use this little bar right here. All right, but we can do it. Let's set this up. So we have tangent 30 degrees. That equals the opposite leg, which is x, over the adjacent, which is 6 square root of 2. All right, step number 2. We need to solve or rearrange so that x is all by itself. And the easy way to do that is just to move this term up there. So we've got tangent 30 degrees times 6 square root of 2 equals x. Not too bad so far. Step 3, we want to replace this tangent of 30 degrees with a precise value from the unit circle. So we're dealing with the 30 degree. That's this red triangle right here. Again, it's a tangent. We only have cosine and sine. That's what we're going to use. So over here on our scrap paper, tangent of 30 degrees is going to be sine, which is 1/2 over cosine square root of 3 over 2. What that means really is 1/2. Used to seeing it like this, divided by square root of 3 over 2. They're just fractions. And if you remember, we don't divide fractions. We multiply them, flip them, and multiply them. Hopefully what you guys have seen is that you have uh, same number, these positions, they cancel out, and because 2 is divided by 2 one time, this 2 is also divided by 2 one time, so they become ones. Then if you multiply straight across, you have 1 on the numerator and the square root of 3 in the denominator. Now, this is a problem because um, we cannot have a radical in the denominator. So if we multiply it by itself, that's called rationalizing the denominator. What you do to the denominator, you must do to the numerator. What that does on the top, it gives us square root of 3. This becomes 3. So that is what we will replace tangent of 30 degrees with. So that's square root of 3 over 3 times 6 square root of 2. There we go. And the last step is step 4. We want to solve the equation. Well, we have the square root of 3 times the square root of 2, and that gives us the square root of 6. We have the 6 here, nothing to multiply it by, and we have the 3 in the denominator, nothing to multiply it by. All right, then these are whole numbers right here, the 6 and the 3, so they can be reduced to 2. This is already reduced, so final answer is 2 times square root of 6. This is our final answer for that one. Good job. So why don't you pause the video here and see if you can solve number 4 by yourself. Your clues are you have a 60-degree angle and you're looking to find side X, Y. Here, I have the side right here. Okay, so pause the video and see if we get the same thing. Okay, let's see if we got the same thing here. We have the opposite right here, the opposite leg. But what we're looking for is the hypotenuse. That's the one we don't have. In that X, I noticed that that's a sine ratio, opposite over hypotenuse. I plugged in my values for opposite and the hypotenuse. Then what did I do? Oh, I rearranged. I slid these guys to their proper places. I solved for X, made that pretty easy. Then I replaced this sine value here, sine of 60-degree angle, which is the green one right here. Sine is square root of 3 over 2. So that's what I replaced this with. Okay. Then now I stopped there because what I was going to show you is dividing that out. We have 5 times the square root of 3 over square root of 3 divided by 2. Okay, so what we're going to do is multiply because we're not going to divide because they're fractions. So pretty much what that is 5 square root of 3 times, I'm going to flip this, 2 over square root of 3. What that gives us in the numerator, 10 times the square root of 3 over square root of 3. You remember, you can't have that radical in the denominator, so to multiply it by itself and do that numerator. So in doing that, here, that gives us 10. When you multiply the square root of 3 by the square root of 3, that gives us the actual number of 3, whole number also. And same deal down here, becomes a 3. All right, so what that pretty much leaves us with is these guys cancel out. That just leaves us with 10. So we have x equals 10. Now, one thing I could have done is didn't have to do all this stuff. This here. You notice I could have canceled these guys out and just left it with 10. Okay? Well, I hope you did a good job with that. All right, we're on to example number 5. And always pay attention to the directions. Like I said before, you wouldn't get into a car and start driving and not even have destination in mind. So we need to know what our goal is here. Here they said an integer or decimal rounded to the nearest tenth, which is good news because that means we get to use the calculator and hopefully I'll be able to bring that up here on the screen. I'm going to try. So if you notice on this one, we have a 56-degree angle. That is not over here on our special triangle. So that's out for now. But we get to use a calculator, which is a lot easier. So what we have is the opposite side, and we have a hypotenuse. So that will give us, we are dealing with the sine of a 56-degree angle, and that is the opposite side, which is 4.5, over hypotenuse, which is x. We don't know what that is, but have to do step number 2. We want to solve for x, get x by itself. So I'm going to switch these guys out. That'll get x by itself. X equal 4.5 over sine of 56 degrees. I'm going to try to bring in my calculator. Hey, I think I did it. I hope this is working. If not, I'll have to fix that. So what we have to type in here is that equation that we had, and it was 4.5 divided by the sine of 56. So we just go over here. It's going to be a fraction, so let me show you. On this calculator, you hit alpha and the y, and it brings up the fraction box. That's the one I want. Maybe I have to do it like this. Oh, maybe I have to do it like this. Enter. Okay, I'm not used to doing it on the computer. In the numerator, we have 4.5. In the denominator, so you got to go down, we have sine, which is this button right there, of 56. And then we want to close the parenthesis. Always scooch over. Press enter. What did that give us? I think that's correct. Hang on. Okay, it was a perfect example of what was wrong. If you get a wrong answer, which I knew that it was wrong, you have to go into the mode button right here. Press mode. And if you see right here, it says radian and degree. Let's go down there. Go over to degree. We want our answers in degrees. So press enter. All right, now to get out of this screen, we hit second mode, and that takes us back to the other screen. So let's type that in again. Hang on, I'll get that. Oh, I'll show you again. Alpha y brings up my my fractions, and this is the one that I want. This is for a mixed number, like if you have a whole number and a fraction, but I want the first one because it brings up the boxes like this. I'm going to type in 4.5 in the numerator. Right arrow goes down. Excuse me. Sine of 56 degrees then I need to close the parenthesis. I like to go over, press enter, and our answer is 5.42. All right, our answer is 5.42. So we need to round it to the nearest 10. So x equals 5 point. This is just a 2. So we're going to leave it at 5.4. That should be good for IXL. Pretty much have all that you need to do that section, but I thought I'd show you another one real quick with the calculator. Guess we don't even need all of that, but this is the important part. I knew that I had a the tangent ratio of 40-degree angle. So it's opposite over adjacent. Then I rearranged it to solve for x. Now we need to find out what x is by using our calculator. So I'm going to show you that again. So here we are at our TI-84 plus calculator. I need to put in that fraction of 5 divided by tangent of 40. Right? So first thing I need is a fraction bar. Hit alpha, y, and I just hit enter because that's the box I want. In the numerator, I'm going to type 5. Then I go down, hit the tangent button right there, 40 degrees, close the parenthesis. I always pop over, which is probably not necessary. Push enter, and it gives us 5.95. So we will take that over to our other screen. And so that gave us 5.95 there. And let's see, they wanted it rounded to the nearest tenth. So this 5 tells us to bump this up, which kind of bump this up to 6. X equals 6. That one. Good job. So that's the end of that. And hopefully that's all that you'll need for that. You did a good job, and I will see you next time.